After adding all that to club with intersection, that is with multiplication. So that's why we are calling it is a conjective normal form is the product of elementary sums. The product of elementary sums is known as conjective normal forms. And let me do the problems how we are going to convert the digit to given prepositions into DNF, that is digit normal form. How we are going to convert the given prepositions into CNF, conjective normal forms. Okay, let me discuss the few examples based on this. Yes. I will share the notes. Just 1 minute. Okay. See here. Let me finish all this. Just I am going to explain the DNF, digit normal forms. Yes, so these are the basic introduction part and normal forms. Of course, we discussed this. Yes. Before starting the problem, just see the what is sum means dissection and product means conjunction. How we are going to do the calculations while simplification into the PDF and PDNF and PCNF. That is principal disjunctive normal form, principal conjunctive normal form. So here, whenever the x3 equal to combination of prepositions, then with the help of this Boolean operators 0 and 1, the sum should be like this. So see this table, uh, 0 plus 0, it is 0. 0 plus 1, it is 1. That is dissection. 0 union 0 is 1. 0 union 1 is 1. And next, 1 plus 0, it is 1. 1 plus 1, it is 1. It is not 2, it is 1 plus 1 means it will become 1. Next, if you take product conjunction, that is product 0 into 0, it is 0. 0 into 1, it is 0. 1 into 0, 0. And 1 into 1, the result will be 1. So based on these properties, we can discuss about the DNF, disjunctive normal forms. So here, first coming to the definition. A product of variables and their negations. A product of variables and their negations are called an elementary products. For example, if you take only one single proportion, it should be P, and whose negation will become negation P. If it is Q, negation Q. If it is some another statement R, its negation in terms of negation of R. So next, negation P intersection Q or P intersection Q. Whatever the prepositions we are going to take, that should be clubbed with product, that is intersection. So that's why I'm saying the definition is the product of variables and their negations. The product of variables and their negations are called elementary product. So these are the few examples for elementary product. P or negation P or P intersection Q or negation P intersection Q or negation Q intersection P, like this. Okay. Similarly, coming to the elementary sums. What is the meaning of elementary sums? A sum of variables and their negations. Yes, I will repeat once again. A sum of variables and their negations are called an elementary sum. Okay. For example, see here. For example, P, negation P. The statement whose negation, neg P or negation P or P union Q or negation P union Q or negation Q union P or negation P union negation P. All these are comes under the elementary sums. Okay, so these are comes under the elementary sums. So we are clubbing more than one prepositions with a union combination or some combination. These are the elementary sums. Next, coming to the what is the meaning of factor. These are the basic terminology. Before going to start the DNF, just listen all this. Factor means any part of an elementary sum or product is any part of elementary sum or product which is itself an elementary sum or elementary product is known as factor of the original formula. So whatever the original formula is given, for that formula we are taking the elementary sums or elementary products. That quantity is known as factor. I will repeat once again here. Any part of an elementary sum or elementary product which is itself an elementary sum or product is known as the factor of original formula. For example, Q, negation Q, P intersection negation P, or Q intersection P, or negation Q intersection P. Like this, all these combinations are comes under the same factors. It can be written like this: negation Q intersection P intersection into two types. Just now I explained. Just we'll go through by detailed. So there are two types of normal forms. One is disjective normal form (DNF). Another one is conjunctive normal form (CNF). Okay. First, let me discuss the DNF, disjective normal form. The disjective normal form is which is a formula which is equal to given formula and which consists of sum of elementary products. Yes, just now I explained. What is the meaning of DNF? It is simply just remember this word: sum of elementary products. All product form. So, what is the definition of this? A formula which is equivalent of all sum of elementary products. Is any preposition written like this: C, which is equal C1 union, C2 union, C3 union, and up to Cn. Individual C1, C2, Cn values, they are products. Statements, variables, or its negations, or its conjunctions of variables. Like example, C1 is either P intersection Q, or C2 is negation P intersection Q, or C3 is negation P intersection Q, whatever it may. So C1, C2, they are the actions, okay, are intersection part of prepositions. And these all C1, C2, Cn can be clubbed with union combination. That is DNA. Okay. If you do one example, it will be very clear. Just listen the first definition. This is about disjective normal form. Okay. Let me do few examples. Yes. See here. The questions are like this. Okay. In your final exam, definitely we'll get the one long answer question from these two topics. One is the disjective normal form, or another one is conjunctive normal form. Let me do the examples on DNF, disjective normal form. So what is question? For example, the format will be like this: P negation P, or P union negation Q, or P intersection Q union negation or intersection S. See these examples here. In this, I am taking four prepositions P, Q, R, S, and I am clubbing these uh, this preposition with union, that is summation. All products can be clubbed with summation. See here, P intersection Q. Assume this is C1. Negation or intersection S. Assume this is C2. So these C1, C2 are combinations of products of two prepositions. Okay, P intersection Q, negation or intersection S. And finally, what we are doing, we are clubbing these C1, C2, that is intersection parts with union. That is C1 union C2. That is C1 means P intersection Q union negation R intersection S. This is DNF, disjective normal. Okay, or the disjective normal form. If you see example second one, negation of P union Q union R. Of course, here also we have three statements, three prepositions. But what is first one? P union Q. Second one R. But these two are clubbing with union. But these two are already sum of. But P union Q is not a product. It is a sum of two prepositions. So this is not a DNF. It is not a DNF format. Why? Because what is the definition? According to definition of DNF, the two or more prepositions can be clubbed with union. Of course, here clubbed with union. But what is C1, C2, C3 here? C1 is again it is a combination of addition only, the sum only. There is no products. So it is not the sum of elementary products. That's why we are calling it is not in DNF. It is not in disjective normal form. Okay. Similarly, see here, second one. Negation P intersection negation Q union R. Yes, this is DNF. Why? Because we are clubbing the products into combinations of union. Negation P intersection negation Q. Assume this is C1 and R is assume C2 is R. We clubbing two products with summation. So this is DNF. Let me do in more detailed with one example. So my question is, write the following as a PDF, principal disjective normal form, or simply you can disjective normal form. What is the question? P double implies Q, that is P biconditional Q. P biconditional Q. So we have to write this as a disjective normal form. Is it clear? So my question is P double implies Q. What is my aim? To write this as a disjective normal form. So we have to write this as a combination of the products of elementary sums. So first let me write this PW implies Q into its principal equivalence formulas. Okay, its equivalence principles. So what is P implies Q? P implies Q already we discussed this in previous last class. In last week we discussed the problems based on P implies Q, P W implies Q. What is P W implies Q? P biconditional Q formula is P implies Q intersection Q implies P. Okay, this is the formula for P W implies Q. So what is P W implies Q formula? P implies Q, P conditional Q intersection Q conditional P. Again, what is P implies Q formula? Is we need to write this conditional formula into combination union formula. What is P implies Q formula? Negation P union Q. Okay, P implies Q formula, negation P union Q intersection Q implies P formula, negation Q union P. Right? Is it clear? So I converted these into combination of union as well as intersection. Still, it is not in a DNF formula. We need to convert this as a sum of products. So again, I am going to apply the distributive property. Negation P union Q intersection, negation Q union P. Right? Distributive law. What is the distributive law here? A intersection B union C. A intersection B union C can be written as A intersection B union A intersection. I'm going to use here right distributive law. What is right distributive law property? A intersection B union C can be written as A intersection B union A intersection C, where here A is the place of, in the place of B we have negation Q, in the place of C we have P. Okay, so A intersection B union C can be written as A intersection B union A intersection C. So A intersection B means A means here negation P union Q. So negation P union Q intersection B. Intersection B means negation Q union. Again A intersection C. What is A here? Negation P union Q intersection C. C means P. So it will become negation P union Q intersection P. Next, it implies, again, I am applying the associative property. Negation P union Q intersection negation Q can be written as negation P union Q of intersection of negation Q. Similarly, union, second function. Negation P union Q intersection P. If you apply the associative property, it will become negation P union Q intersection P. Again, go for the next. Negation P union Q intersection negation Q. Again, go for the distributive property. Apply the right distributive property. It is in the form of A union B intersection C. So what is A union B intersection C? A intersection C union B intersection C. Okay, 1 minute. Okay, so it is in the form of right distributive law. What is right distributive law? Huh? ఉన్నాయి సార్ ఉన్నాయి సార్ అదే ఉన్నాయి మిగిలినాయి 40 రూపాయలు అయినాయి 10 రూపాయలు చాయ్ ఉంది చెప్పండి ఆరాంగా చెప్పండి ఓకే సో apply the right distributive law. Right distributive law. What is right distributive law? I am applying the here A union B intersection C. In the place of A, I have negation P. In the place of B, I have Q. In the place of C, I have negation Q. So if you apply A union B intersection Q, it will become A intersection B union A intersection, sorry, B intersection C. So it means we'll get negation P intersection negation Q union Q intersection negation Q. Okay. Similarly, coming to the second function also. In second function also, see here, again it is comes under the right distributive law. A union B intersection C. In the place of A, here I have A is negation P, B is Q, and C is P. So what is negation P union Q intersection C? It will become A union B intersection C means A intersection C union B intersection C. So if you apply that formula, it will become negation P intersection negation P, sorry, negation P intersection P union Q intersection P. Okay. Next, come to the next step. So what is negation P intersection negation Q value? I'm going to write that is as it is. Negation P intersection negation Q union C. Second one is, what is Q intersection negation Q? So one preposition, it's a negation preposition. If you apply the intersection, it will become false. Okay. So these are the fundamental properties we discussed at the beginning of the class. Okay. Q intersection negation Q means it is a false. Okay. Next, union of. Here we have same principle. P negation P intersection P. Again, it will go to false. Union Q intersection P. Okay. Next, any principle with union of P, it will get same that principle. So P union F, P union false means again it indicates P only. So in the place of P here we have negation P intersection negation Q. So negation P intersection negation Q union of C union of F will become negation P intersection negation Q union. Again here F union Q intersection P is there. F union Q intersection P means again any preposition union with false, we will get the same that preposition. So we will get Q intersection P. So finally, I got two preposition C1 union C2, where C1 is negation P intersection negation Q, and C2 is Q intersection P. So here C1 is product of two prepositions, negation P intersection negation Q, and Q2 is also product of two prepositions, Q intersection P. So I am clubbing these two prepositions. Yes, listen carefully. I am clubbing these two prepositions, that is product of two prepositions, with union or with sum. That is negation P intersection negation Q union Q intersection P. So this is disjunctive normal form. Okay, is it satisfying this definition? Yes. What is disjunctive normal form definition? C can be written as the combination of C1, C1 union C2, where C1, C2 are product of two prepositions. Okay, yes, it is written as the elementary sum of the sum of elementary products. Yes, I will repeat once again. The finally it can be written as finally this principle can be written as this principle can be written as the sum of elementary products, negation P intersection negation Q union Q intersection negation Q intersection P. So what is actually our question? P double implies Q. So P double implies Q can be equivalence to, it can be written as equivalence to, yes, can be written equivalence to negation P intersection negation Q, negation P intersection negation Q, union Q intersection P. So this is disjunctive normal form. Okay. Next, let me discuss one more example. Then it will be very clear. See here. Okay. Before that, let me discuss the conjunctive normal form. Let me finish this. After completing this topic, simultaneously I will explain the examples for CNF and DNF. Now, next topic. Another second form. Second one is, first one we finished this disjunctive normal form. We finished it. Next, second one, conjunctive normal form. CNF. So, what is the definition of CNF? It should be product of elementary sums. It should be product of elementary sums. Coming to the definition, a formula which is equivalent to a formula which is equivalent to a given formula and which consists of a product of elementary sums. Please listen this sentence. What is CNF? Conjunctive normal form is a product of elementary sums. A product of elementary sums is called conjunctive normal form. In detailed, and it can in notation it can be denoted like this. If D is a CNF, I want to write D in terms of CNF, then it can be expressed as D can be equivalent to D1 intersection, D2 intersection, right up to intersection DN. So, what is the individually D1, D2, DN? They are unions, union of two or more prepositions, where all DIs, each DI is either a statement or its negation or disjunctive of the such variables or their negations. For example, it should be for examples here, P or negation P. So what about D1, D2 up to DN? They should be either of these formats, only preposition or only negation of preposition or disjunctive combinations. P negation Q or P union Q. D1 means P1 Q or negation R union S. Here, this is the best example here. P union Q intersection negation R union S. In this, D1, D2 clubbed with intersection. That is, sum will be clubbed with product. P union Q, assume that is D1. Negation R union S, assume that is D2. These two are clubbed with intersection. So that's why I'm calling this is a conjunctive normal form. Is it clear? Let me discuss few examples. Yes. Obtain the CNF, that is conjunctive normal form for the following preposition. What is our preposition? P intersection P implies Q. Yes, listen carefully. The question is P intersection P intersection P implies Q. So write this as a conjective normal form. So first P intersection, and I'm converting this P implies Q. I'm converting this P implies Q as a union combinations or intersection combination. What is P implies Q formula? Negation P union Q. Okay, P implies Q. We did these formulas in last week. We discussed a few examples also with the two tables, without two tables. I am using that same principles, the equivalence principles. So P implies Q. P implies Q can be written as negation P union Q. So P intersection P implies Q can be equivalent to negation P intersection, sorry, intersection P implies Q can be written as P intersection negation P union Q. P implies Q can be written as negation P union Q. Okay, CN. Of course, automatically it comes under the CNF. No need to expand the distributive or some other formulas. Why? Because here negation P and Q is assume that is D2 and P is D1. So we clubbed these two prepositions with intersection. So negation P and Q is disjunction form and P also disjunction form. These two disjunction forms can be clubbed with intersection. Means two elementary sums can be uh, clubbed with intersection. So this is conjective normal form. Let me do one more example. So obtain the CNF of, that is conjective normal form of P implies P implies P implies Q intersection negation of negation Q union negation P. Okay, I want to convert this as a conjective normal form. Conjective normal form. Okay, P implies Q, P implies Q, P implies Q intersection negation of negation Q union negation P. Okay, so first I'm not going to disturb the P preposition. I'm writing that is as it is. P implies Q, and we have P implies Q here. P implies of P implies Q. First write this P implies Q as a negation P in Q. Okay, just now we used this formula, same formula in above examples here. So P implies Q is, what is P implies Q? It is negation P union Q, negation P union Q. And intersection, we have one more preposition, that is negation of negation Q union negation P. So write this as a intersection of, apply the De Morgan law here. What is De Morgan law? Negation of P union Q will become negation P union will become intersection. Intersection negation Q. Okay. If it is negation of P intersection Q is there, then intersection will become union. So here we have negation of negation Q union negation P. So it will become negation of negation Q, that is Q, union will become intersection, that is intersection of negation P. That means P. So after applying the De Morgan law, it will become negation of negation Q union negation P will become Q intersection P. Okay. Next, it is implies as, again see here, apply same principle. P implies Q principle for here. But in the place of P, we have P itself. But in the place of Q, assume this entire statement is Q. That is negation P union Q intersection Q intersection P. So first I will going to apply the P implies Q formula. What is P implies Q formula? Negation P union Q. So P implies this entire statement will become negation P union, and write that is as it is. Q is as it is. Negation P union, negation of P union Q intersection C. After this, what is our aim? To write this as a conjective normal form. For reducing that into conjective normal form, again, see here, I'm going to apply the distributive properties. What type of distributive property? Right hand distributive property, or simply right distributive law. A union B intersection C. Yes, listen carefully. A union B intersection C. What is A union B intersection C formula? A intersection C union B intersection C. Is it clear? A intersection B union B intersection C. In the place of A, here I have negation P. In the place of B, I have Q. In the place of C, here I have Q intersection P. Is it clear? Now apply the right distributive law for above statement. Therefore, it is negation P union A intersection C. A intersection C, it will become negation P intersection Q intersection P. Union B intersection C. B intersection means Q intersection P. Okay. Next, it implies negation P union negation P intersection Q intersection P. Here we have three prepositions. One is negation P, one is Q, one is P. So first apply the associative property negation P intersection P intersection Q. But what is negation P intersection negation P intersection P? It will become false. A preposition whose negation club this with intersection, the result will goes to false. Okay. So negation P intersection P means it is false. Intersection Q union. Similarly, here also we have three prepositions Q intersection P. So Q repeated twice. So right, it has a intersection A means it is A itself. So Q intersection Q means it is Q itself intersection P. Okay. So it will become Q intersection P. Next step, negation P union and F intersection Q. Because negation P intersection P, we got F, that is false. F intersection Q union Q intersection P. Next step, negation P implies F intersection Q. Any preposition with F with the combination of intersection, that will become false only. P intersection F, that is F only, that is false only. So negation P union F intersection Q will become false. Union Q intersection P. Next, any preposition union with false, that is same preposition will get. That is P union F means we will get the P preposition only. But here in the place of P, here we have Q intersection P. So Q union Q intersection P means we will get the same preposition Q union Q intersection P. So finally I got negation P union Q intersection P. So next, negation P union Q intersection means again here I will going to apply the distributive property, left distributive property. What is that left distributive property? A union B intersection C. A union B intersection C. What is A union B intersection C formula? A union B intersection B union, sorry, A union B intersection A union C. But in the here in the place of A, I have negation P. In the place of B, I have Q. In the place of C, here we have P. So A union B intersection C will become A union B intersection A union P. So it will become negation P union Q intersection negation P union P again. So negation P union Q, that is as it is. And what is P union of their preposition, their negation function? P union of its negation function. It will become true only. Okay. Already we discussed this formula at the beginning class itself. So P union negation P is always true. So finally I got negation P union Q intersection true. So any function, any preposition with true with the combination of intersection, we will get the same that preposition. So negation P union Q intersection P will become negation P union Q. Negation P union Q. So this is the conjective normal form. Why? Because I clubbed combinations of union with intersection. Of course, here we have only D1. We don't have any D2, D3 years here. If more than one preposition is there, then I clubbed with intersection part. All that unions will clubbed with intersection. But here we have only one preposition, that is combination of additions, sum. Here we have only one combination, negation P union Q. So that is the final answer. So this is conjective normal form. Let me do one more example. Let me do one more example. So here, see here, write the following preposition as a conjective normal form. What is our question? Q union P intersection negation Q union negation P intersection Q and negation Q. First, identify how many prepositions are there in this entire question. We have only two prepositions. One is P, one is Q. And he is asking, write this as a product of elementary sums. That is conjective normal form. Just coming to the step by step simplification. So negation P union Q by conditional P intersection Q. It is equivalent to S. Just now we did in previous example here. What is P W implies Q formula? Where it is P W implies Q in previous example. Yes, this P W implies Q formula is P implies Q intersection Q implies P. So I'm going to apply the same principle here. But let me check out what is P value, what is Q value. So in this example, uh, so sorry, this one. What is our question? Q union, Q union, P intersection, negation Q union, negation P intersection, negation Q. So first let me do this as a, uh, of course this is a tautology example. This is not required because finally we will get the two tautology. In last class we discussed the tautology, contradiction, contingent. Again, I'm not going to discuss that one. Let me do directly example number 4. This is, I want to convert as a CNF, conjective normal form. So what is our question? Negation of P union Q. Double implies P intersection Q. So for this problem, for getting the simplification, I am going to use the P W implies Q formula. What is P W implies Q formula? I written here. P implies Q intersection Q implies P. Is it clear? P double implies Q formula is P implies Q intersection Q implies P. So in this example, compare what is P value, what is Q value here. P is negation P union Q and Q is P intersection Q. For this, if you apply the above formula, it will become negation P union Q intersection, negation P union Q double implies P intersection Q. It can be written as negation of P union Q implies P intersection Q. That is, what is formula? P implies Q union intersection Q implies Q. So in the place of P here we have negation P union Q. The place of Q here we have P intersection Q. So if you write this as a above formula, P negation P union Q implies negation, no, sorry, P intersection Q. Intersection Q implies P. That is P intersection Q implies Q. What about this? Negation P union Q implies P intersection Q intersection of P intersection Q implies negation P union Q. That is P implies Q implies P. In the place of Q, I have Q intersection P intersection Q. In the place of P, I have uh, negation of P and Q. So it is Q implies P. Q implies P means P intersection Q implies negation P union Q. Next step here. Next step. negation of P intersection negation Q. Now I'm going to apply the De Morgan property. De Morgan laws. What is De Morgan laws? Say negation of P implies Q will become negation P, union will become intersection. Intersection negation Q. So this is negation P intersection negation Q implies. I'm writing P intersection Q. I'm not going to apply any formula on P intersection Q. So write that is as it is. P intersection Q. Intersection. Coming to the second function. P intersection Q. P intersection Q implies negation P and Q. Now for this, here I'm applying the P implies Q formula. What is P implies Q formula? Negation P union Q. In the place of P, I have P intersection Q. In the place of Q, I have negation P union Q. So if you apply the P implies Q as a negation P union Q, then it will become negation of P intersection Q union negation of P union Q. Next again, here in the first function, I am writing as it is. Just apply the De Morgan property. Now, P intersection negation formula. P implies Q formula is negation P union Q. But in the place of P, I have negation P intersection negation Q. And in the place of Q, I have P intersection Q. So apply the P plus Q formula. Negation of P. Negation P intersection negation Q. Union P intersection Q. So Q I am writing as Q. Intersection. This is again here. So for second quantity, I am going to apply the distributive properties. Okay. Negation P. So first, before going to distributive property, first apply the De Morgan property, because negation of P intersection Q is negation P intersection will become Q. Union negation Q. Union of negation P intersection negation Q. Here also apply the De Morgan property. Negation of P union Q. So negation P union will become intersection. Intersection of Q will become negation Q. Next. So if you apply the De Morgan property here also, negation of negation P intersection negation Q. Already inner function, inner preposition, we have negations. So negation of negation P will become P. E intersection will become union, and negation of negation Q will become Q. Union P intersection Q. I am writing as it is. Here negation P union negation Q. Union negation P intersection negation Q. So here I am applying the left distributive property. A union of B intersection C. A union of B intersection C. In the place of A, here I have negation of P union negation Q, and I have B is negation P and Q is negation Q. So for this, if you apply the left distributive property, that is A union B intersection B union C. What about this formula will can be reduced to here. This is general simplification. Just I am applying the same formula two times. Okay. So, so this is the negation of P, negation P will become P, intersection will become union, and negation of negation union, and write B intersection Q as it is, and here if you apply distributive property for this, it will become negation P union negation Q union negation P intersection. Due to signal problems, it is disconnected. Please stay on. I will share the notes. Yes, this is it. So this one. Let me finish last steps here. So P and Q union P intersection Q. So I'm applying the A and B intersection C. The formula will become A and B intersection A and C. Here A means P and Q, B means P, Q means C. So A union B means P union Q union P intersection A union C means P union Q union Q intersection, and write this as C. So what is A union A? A union A means again A. So negation P union negation P will become negation P only. So negation P union negation. And here also negation Q repeated twice here. Negation Q union negation Q will become negation Q itself. So it is negation P negation Q. So next P union Q union P. Again it is P repeated two times. What is P union P? It is P itself. So P union Q intersection here Q repeated two times here. Q union Q. So it is Q itself. So P union Q repeated two times. So P union Q repeated one time only. So see how many they write it in. Finally, I am going to write these as a Q intersection negation P union negation Q. So finally, I got this format. This is just check out whether it is a CNF or not. Yes, here we have D1, D2, where D1 is P union Q and D2 is negation P union negation Q. Means two disjective forms, two sums clubbed with intersection. Two disjunction forms clubbed with intersection. So it is the it is the product of elementary sums. Therefore, it is conjective normal form. This is CNF. Okay, is it clear? And let me do next. Coming to the one more example. See, yes, here also I have one more example. Just I'll explain this. So, what is our question? Negation P. Yes, this is the last example. Just listen. Negation P implies R. Negation P implies R intersection. All these are just practice examples. Okay. In your final exam, they will ask these type of questions only. Yes, sir. Then carefully. So negation P implies R intersection Q double implies P. Okay. Right. No? Yeah, upset. So this is also one more example for conjunctive normal form. Let me do how we are going to convert this into conjunctive normal form. So what is our question? Negation P implies R, intersection Q double implies P. So first apply the P implies Q formula. What is P implies Q formula? Negation P union Q. Similarly, Q double implies P formula. What is P double implies Q formula? Q intersection Q implies P. So I am using the two formulas here. So question is negation P implies R, intersection Q double implies P. So negation P of negation P union R, intersection Q implies P will become Q implies P intersection P implies Q. Next here, negation of negation P will become P union R, intersection. Again here Q implies P is there. What is Q implies P formula? Negation P union P, intersection. What is P implies Q formula? Negation P union Q. So finally I got the formula. Final quantities, all sums can be clubbed with intersections, that is products. So P union R, intersection, negation Q union P, intersection, negation P union Q. The combination of D1 intersection clubbed with conjunctions, intersections. Is it okay? So this is final disjunctive conjunctive normal form. All three prepositions are three disjunctions. D1, D2, D3 are clubbed with product, clubbed with intersection. This is known as conjunctive normal form. Okay, like this we can do some more examples. Next, I will going to start the next topic. That is obtain the just do practice problem. This convert it into CNF. So next topic is principal disjunctive normal form. Now PDNF, that is disjunctive normal form into. Next topic is we are okay. It is 11:30. Just within 2 minutes, I will close the class. Next class we will discuss the how DNF, disjunctive normal form, into principal disjunctive normal form, and how we are going to convert CNF, conjunctive form, into principal conjunctive normal form. Okay, these two are the extension topics of DNF and CNF. So before starting that one, just we have to check out how many total prepositions are there in given question. So in each and every individual C1 or D1, either it may be sums or products, we have to check out whether it consists all prepositions or not. If it is anyone is missing, include that one by using either union combinations or intersection combinations to write it into disjunctive normal form or conjunctive normal form. And finally, we have to check out in each and every individual C1s or each and every individual D1s, all prepositions are present or not. With the help of that, we can write into finally conjunctive normal form or disjunctive normal form. Okay. Okay, almost it is 11:31. Okay, we'll stop the class. In next class, I will going to continue the next principal disjunctive normal form, principal conjunctive normal forms. Okay. Now we're going to stop the class. Let us continue next class.